There we go. All right, so 11. So this chapter, we're wrapping up chapter 11 here. This chapter is all about. Oh, wait a minute, I got a problem with my pencil thing here. I forgot. This chapter is all about solving systems, and a system means more than one equation at the same time. So two equations at the same time. How do we solve them? See if that takes care of it. Yeah. All right. So let me take that first equation. There we go. All right. So they're going to give us two equations at the same time, which is not new. We've done two equations at the same time. But what's different here is they're non-linear. Do y'all know what that means? What does that mean to say an equation is non-linear? Adding and multiplying? First of all, what's a linear equation? How about that? If we're non-linear, let's be clear. What's a linear equation?
The one that doesn't have a power in it?
Right. Linear would be like y equals mx plus b. Yeah, meaning x is first power and y is first power. Totally. Yeah, meaning the picture is going to be a line, huh? A linear equation has x and y to the first power, meaning the picture will be a line. That's linear. So non-linear means it's not a line. The picture is not a line because it's not first power. Exactly. See how these guys have second powers? And this one, the x and the y are multiplied which instead of added, which actually means it's not a line either. So yeah, so both these are not, so these are curved kind of things. So we're finding, now we're dealing with systems where they're not just a bunch of straight lines, and where do they meet? We're dealing with a bunch of curved kind of graphs. We're not going to graph them, but that is what's going on. So I don't think they want us to graph any of these. Anyway, let's solve it. So I think you know how to do this. I don't think you totally need me to show you. I think you could basically do it. What would you suggest? How are we going to solve these two equations at the same time? What would you try to do?
Get either y or x on one side.
Exactly. Yeah, just get x or y alone in one of them, huh? And plug into the other. That's exactly right. That's exactly what I'm going to do. So I always just try to start with whichever one looks easier. That top one looks a little easier to me. So I'll just get x alone in that top one and plug it into the bottom one. Exactly. Or y. You can do y. It doesn't really matter. So, yeah, I'll just divide by y, let's say. So x is 2 over y. And then I'm going to plug that into the other equation. You always plug one equation into the other, right? Substitution method. And so I'll just plug that in right there for x. Because x equals 2 over y, I can stick it in there. Like that. We good to there? And all making sense? Just plug 2 over y in for x in the other equation. Now, how can we solve this thing? Well, let's square this guy. Let's square the 2 over y. So that would be square the 2, square the y. So that's 4 over y squared. We good to there so far? Just square the 2, square the y. And now, what do we do with like a whole number like 2 multiplying a fraction like 4 over y squared? How do we deal with that? What's the 2 do? It's over 1, right? So it goes to the top only. 2 times 4 on the top there. So it's going to be, what is that? 8 over y squared plus y squared is 6. Yeah. Good so far? All right. I'm going to, if you're okay to there, I'm going to go to fresh screen here so we can keep working. These are a little bit long. I think they're pretty regular. I think you know what to do in general. They're just kind of long. So 8 over y squared, what is it, plus y squared equals 6. Now it gets a little more tricky. We're trying to solve that thing. What should we do to solve that thing? Yeah, right. Multiply by the denominator, huh? That's pretty much what we always do. Whenever we have fractions, whenever we've got denominators, yeah, whatever's in the denominator, just multiply through by that denominator. Exactly right. So I'm just going to multiply through by y squared, y squared, y squared. That makes sense? You just always multiply by the denominator. And right here it cancels, huh? That's why we're doing it. We want that one to cancel. And so then we get 8 plus y to the 4th equals 6y squared. Good to there. And now we should take this one and jump it over here and get a 0. So and I'll put them in order, highest power to lowest. We good to there? And did you know we can actually factor that now? That's actually factorable. And so, I'll say y squared, y squared. See how we're factoring at y squared times y squared to be y to the 4th there? And then, what multiplies to be 8 and adds to be the minus 6? What times what is 8? And can somehow make minus 6 in the middle.
-4 and -2.
Yeah. Very good. Minus 4 and minus 2. Because two negatives multiply to be positive 8, and they add to be the negative 6. And then what do we do from here? You have two things that are timesing to equal 0, right? The two parentheses are timesing to equal 0. Remember, if two things are timesing to equal 0, then either one could be 0, huh? Right? If 0 times anything would be 0. If the first one was 0, 0 times anything would be 0. Or if the second one was 0, it'd be 0. So either way, so it means y squared minus 4 is 0, or either the first one is 0 or the second one is 0. Either way, they're going to times to come out 0, huh? So that's what that means. And then you just finish up. We're almost there. So move that over. Y squared is 4. And move this one over. Y squared is 2. How do we turn it into regular y? One more step to regular y. We square root it, huh? And when we do the root thing, what do we have to remember to do? Plus or minus. Real important in this section. You know, I always say put a roof on the house, up and down the ladder. Just to help you remember, when you put a root on both sides, you got to do the plus or minus up and down the ladder. It's my goofy analogy. Plus or minus 2. This one, put the roof on the house, up and down the ladder. So plus or minus root 2. So we actually got 4 answers for y. Plus 2 and minus 2, and plus root 2 and minus root 2. 4 answers for y. And now, it'd be nice if we were done, but we're still got more work to do. We got to find an x that goes with each of those 4 y answers. So let's keep going. This problem will never end. So this is still problem number 1. And I'm going to say, all right, y is plus 2. I'm going to kind of, oops, if I can, I'll break the screen into 4 even columns. So y is plus 2, y is minus 2, y is plus root 2, and y is minus root 2. And with each of those, we're going to have to find an x value that goes with each of those y's, because we're looking for x, y answers that make the thing true. So now, to do that, where am I going to plug in? Right, whenever you get y or x or whatever your first answer is, you got to plug in to get the other one. Where do you want to plug in? Well, the easiest place we possibly can, huh? And that's going to for sure be that first equation, right? That one looks easier than the second. Yeah, so when you come to the plug-in, you guys remember how to do this, right? Whenever you get the first answer, then you plug in to get the other. Always plug into the easier. They'll be very different in the nonlinear equations. You know, there'll usually be an easier one and a harder one. Not always, but. So I'm going to plug into the x times y equals 2. So I'm going to x times y equals 2. So I'm going to plug in the 2 there. So in every case, I'm going to plug into x times y equals 2. And I'm going to plug in the y so I can find the x that goes with it every time. And then I'll get x times 2 equals 2. Divide by 2. X is 1. So that's the answer 1, 2. X and y that go together. Excuse me. And then the next one, x times 2 equals 2. Oh, negative 2. Negative 2. Negative 2. So divide by negative 2. Better make that a little bigger. Like that. And so x is negative 1, huh? So that's negative 1, negative 2. That's the second xy. And then the third one, x times root 2 is 2. Divide by root 2. So x is 2 over root 2. We don't usually leave our answers with a root in the bottom, right? So how do I get rid of that root from the bottom in that x answer there? Multiply. Yeah, one thing you could do, here's what I always do. You don't have to do this, but I always look at the 2. It's just a shortcut. When I look at 2, I just think, hey, that 2, that's root 2. You know, on the top, that 2 on the top is 2 root 2s, and then it just cancels, and I know the answer is just 1 regular root 2. Just a quick way to go. You don't have to do that, and I know that confuses some people, so I'll show the traditional way. The traditional way is just multiply top and bottom by root 2. That's fine. That'll work fine. It's just an extra step. So then you'll get 2 root 2. The bottom, root 2 is plain 2. Everybody good with that? Then the 2's cancel, and there's the answer I was saying it is. Root 2. So it's root 2 comma root 2. That's xy. Excuse me. And now you know what's going to happen on the next one, huh? It's going to be the same thing, right? It's going to be x times negative root 2 is 2. Divide by negative root 2. Boom. So you get 2 over negative root 2. Multiply top and bottom by root 2. You get 2 root 2 over negative 2. They cancel. So it's negative root 2. Move that up. Kind of ran out of room there. And negative root 2. So that answer is negative root 2, negative root 2. You can see that down there. 4 answers. And they want you to type them all in. Just the typing in can take a long time. With commas between them all. Is that okay? Everybody tracking all those answers? Could you read this one down here? Are we good there? So the final answer then, on number 1, what they want you to type in, what is it? So 1, 2, negative. So 1, 2, comma, negative 1, negative 2, comma, root 2, and okay. And then root 2, comma, negative root 2, negative root 2. That's the answer they want you to type in. Those are the 4 points that make that equation true. All right, you know how to do most of that, huh? Most of that was not really new to you in any way, just long and tedious. There's only 27 of these in the section. No, I'm kidding. Is there 9? What is there? Something like that? Questions I can answer on any of that? We good? So it all came about from plugging, well, it came back way back here. You know, solving for x or y in the first equation, plug into the other, and then do a whole bunch of algebra. 10, I think there's 10 questions. Okay, so there we go. 2 pretty challenging equations. They're not linear. Well, the top one's actually linear. The bottom one's not. So, okay. So you know the drill, right? Why don't we solve for x in the top equation? Plug that into the bottom. We'll just do the normal thing. Let's come up here. So x plus y plus 3 equals 0. Jump the y and the 3 to the other side. X equals minus y minus 3. So go ahead and get x alone in the top equation. And then plug that into the bottom. So the bottom equation, x squared plus y squared plus 5y minus 4x is minus 6. So let's take this right here and plug it in for x. Plug it in for x right there in those 2 spots. And then you'll have a big equation with y, and you can solve for y. So let me let you do that for a minute, and then I'll finish it up. I'll give you just a second. So minus y minus 3 squared is going to be 2 of them. plus y squared plus 5y minus 4 times x, and x is minus y minus 3 equals minus 6. All right, we good to there? So just plug it in. So the squared means 2 of them, and then we just gotta FOIL all that out and everything. Just a lot of algebra here. So it'd be y squared. What is it? Plus 3y plus 9, and then plus, and then y squared plus 5y, and then this minus 4 will distribute. Plus 4y plus 12 is minus 6. Look at all that. All right, so then we gather like terms. So y squared and y squared is 2y squared. 3y, 6y, and 4y is 10y, and 5y is 15y. And 9 and 12 is 21 equals minus 6. We good to there? Now what do we do? Get a 0, huh? So I'm going to add 6 to both sides and get 2y squared plus 15y plus 27 is 0. 2y squared plus 15y plus 27 is 0. Good to there, and I'll go to a fresh screen. Everybody good to there? Now that you can solve by either factoring or by the quadratic formula, whichever you prefer. I don't know if it factors. No, that's not going to factor, is it? Is something weird happening here? Interesting. I don't know. Yeah, we got to use the quad. Everybody good to there? Can I go to fresh screen? You good on that? So this is number 3 we're working on here. So number 3, we're down to 2y squared plus 15y plus 27. I didn't mess up, did I? So did you guys get to there as well? Okay, so now we'll do the quad. So you know what I mean by that? The negative b plus or minus the square root b squared. Definitely put this on your 3x5 card for the next test if you don't have it memorized. Negative b plus or minus square root of b squared minus 4ac all over 2a. And that's what y will equal. We're trying to solve for y right now. Right? That's for solving any second degree equation. Any x squared or y squared equation is the quad. So remember that. So a, b, c. So negative b, negative 15 plus or minus square root of b squared. 15 squared minus 4 times a times c all over 2a. And so negative 15 plus or minus 15 squared is what? 225 minus some big number that's too big for me. 54, 108. Is it 216? I think it is. And then that's the root of 9. That's nice. I like it when that happens. Negative 15 plus or minus 3. When that happens when I'm taking a test, I'm like, yeah, I'm getting this one right. Something good's happening. And that all comes down nice like that, right? Square root of 9 is 3. And so bring this up here. So we got negative 15 plus, I was going to do the two options. Remember how to do this from algebra days? Minus 15 plus 3 over 4, minus 15 minus 3 over 4. Remember those two different options there? And that's minus 12 over 4, which is minus 3. Minus 18 over 4, which is it minus 4.5? I think, isn't that right? 16, 28, 16, 17, 18, yeah. Good. So we got those two answers for y. Negative 3 or negative 4.5, 4.5. Now what are we going to do with those? We got to plug them in. Each of those have to lead us to an x, don't they? Everybody good? It's a tedious section. But I think it's mostly stuff you already know. All right, so we got those two y values. So each of those we're going to plug in to get an x. Where are you going to plug in? Where easiest place you can. You know, you can plug in anywhere you want. I'm going to go back and take a look. And wherever is easiest. Definitely this first equation, huh? Looks easier than the second. So always go back and plug into the easier equation. X plus y plus 3 equals 0. So I'll plug in there. Let me go to a fresh screen and take these two answers to a fresh screen. So I've got y, was it minus 3? Minus 3 and minus 4.5. And then I'm going to plug into whatever it is, x plus y plus 3 equals 0. So let's do that. X plus y plus 3 is 0, right? X plus y plus 3 is 0. Yeah. X plus y plus 3 is 0. Plug in the y. Plug in the y. Like that. Minus 3 plus 3, boom. So x is 0. And this one, x, or plus negative 4.5 plus 3 is 0. That means x minus 1.5 is 0. Move it over. X is 1.5. So we get the answer 0 minus 3, right? 0 minus 3 for xy. And we get the answer 1.5 minus 4.5 for xy. And we're done. There we go. That okay? You can do all that, right? It's just a lot of tedious algebra.
It seems like review of earlier stuff, but...
Yeah, it is, huh? I mean, none of this is brand new, right? Quadratic formula, plugging in, and yep. It's good to practice, though. I mean, there's 9 of these. It would be very good for you. I felt like I'm saying take your vitamins, but it would be, as far as you want to go to calculus, a lot of calculus is being good at algebra. It's just a lot of this. So it's good practice just to make you more and more comfortable with algebra. Questions I can answer? All right, I'll move on. There's a couple. Let's see. Okay. Yeah, so there's our 2 equations. Which on this, oh, yeah, no, actually, this is a good idea. Do a few steps on this because this one gets a little messy. Which equation should we start with on this one? The top one or the bottom one? For sure the bottom one, huh? Because easier. Always start with the easier one. So for sure the bottom one, I'll grab this one. So 3x plus 2y is 7. Excuse me. Going to start with that one, and I'm going to, solve for either x or y and plug it in. Here's the problem on this one. It's a little tricky. If I solve for x or if I solve for y, I'm going to get fractions. Do you see that coming? Right? And that's just a little messy to deal with. It's kind of hard to deal with. Yeah. So, 3 things. Let me say 3 things. Just to, this is where there's no substitute for simple experience. Just hours of plugging things into things and working them out. If you have a lot of experience, you can look at this and you can see the easy way through the woods to Grandma's house as opposed to the hard way through the woods. The hard way would be to solve for x here. That's going to be awful. Why? Don't write it down. Watch me take a couple steps and you'll see what I mean why you really don't want to solve for x. It's because there's a 3 there and that 3 is going to be in the denominator. So don't write this down. This is not a good plan. Watch me do it for a little bit. Divide by 3. Look at that. I got 7/3 and minus 2/3. So what? Well, that means I need to plug that in to this one, don't I? Which is going to be pretty awful, especially when it's plugged into this middle one. The front one, something nice will happen, but the middle one, nothing nice will happen. Do you see that? Do you know what why am I making a big deal out of the middle one? That looks easier maybe than that to you. But no, if you can see a little further down the road, something nice will happen with the 9x squared, but nothing nice will happen in the middle, and I'll have fractions that stay. Can you see that? The more you do these, the more you'll be able to see that, and you'll avoid that road, and you'll take the easy road. Let me show you. So watch this. Watch what I'm talking about. If I take all this and I put it in right there, it's going to be 7/3 minus 2/3 y squared, right? So I got to write 2 of them, don't I? And I know you might feel like, that's awful. All those fractions, yeah, but they're all going to have a denominator of 9 when I multiply 3 times 3. And then eventually this 9 in the front will come through and wipe them all out. So it'll be clean in the end. You know what I mean? And let me just finish this one before I go further. This will be 49/9 minus, when this goes here, it would be 14 ninths, and then this y, 14 ninths y, minus another 14 ninths y, plus 4 ninths y squared, and then the 9 will go boom, 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 and just cancel all these guys out. So in the end, we'll just have 49 minus 14y minus 14y plus 4y squared. No more fractions. So that one will do okay in the end, but the middle will not do that. Look what happens in the middle. In the middle, minus 2 of x, there I'm putting in x right there. At least I'm supposed to. So minus 2, put in that x. X is right there. 7/3 minus 2/3 y times another y at the back, right? 2xy, this is x, plus 4y squared is 35. It's getting scribbly here. Okay, and now see here, here's the real problem. That's going to distribute through, oops, not equals. We're going to get minus 14/6 y. The y will also distribute in, plus 4/3 y squared plus 4y squared 35. Look at that. I mean, that's just rough. I mean, you can do it. You could now multiply through by 6. That would get rid of all the denominators. You'd have a whole bunch of others. You can do it. It's just tough. It's just tough sledding, right? Just a tough path. So, rather than that, and why did all that happen? Because of these 3's in the denominator when we solved for x, right? Made it difficult. So, rather than that, what if we solve for y? Am I saying solving for y would be so much nicer? I'm just jumping the 3x to the other side. Divide by 2. Yeah, go ahead and write this down. This is a good plan. This will be better to solve for y. Why? Well, because it only has 2's in the denominator, but it's still fractions. You might think, well, what's the difference? It's still fractions. Yeah, it is still fractions, but when I plug it in to this guy, I'm going to plug it in here, and see how there's a 2 in front? That's going to wipe out that 2, no more fractions. I'm going to plug it in here, see how there's a 4 in front? That's going to wipe out the 2 squared, which is 4, and there'll be no more fractions. This is way nicer way to go. Do you see that coming? So this is the way we want to go. So this is the kind of thing that experience teaches you. Just doing millions of these, and pretty soon. And I'm going to show you a third way in a minute that's even more tricky, where you don't even touch a fraction, but that's not normal. But there is this one's open to it. So anyway, let's just do this. This is what I think you, at this point, at your experience level, could probably see and go, okay, yeah, I see y is easier than x. I'll do the y thing. Let's plug that in. Let's take this top equation. So 9x squared minus 2xy plus 4y squared equals 35. Excuse me. Plug all of this in for y and y in those two locations. So what do we got? 9x squared minus 2x, and then comes y, which is 7/2 minus 3/2 x, plus 4, and then y squared. You know what y squared means? 2 of them multiplied. 7/2 minus 3/2 x, and then another 7/2 minus 3/2 x. I mean, it's still pretty messy. This is a messy problem. Equals 35. So there we go. But the fractions will go away because of some of the numbers in the front that are multiplying. So now distribute. 9x squared minus, this 2 will cancel this 2. 7x, and it'll cancel that one. Plus, watch your signs. Don't drop one sign. Plus 6, no, not 6, the 2 is canceled, huh? Plus 3x squared. Everybody good with there so far? No more fractions there, nice. Now this one, now what's going to happen here? Well, leave the 4. Remember when we have 3 things that need to multiply, you got to do the parentheses first, just leave the 4 in the front? So let's leave the 4 sitting in the front, and then do these parentheses. Boom, boom. That would be 49/4 minus 21/4 x, and then this guy will go to both. Minus, pen's having trouble today. Minus 21/4 x plus 9/4 x squared. All that equals 35. All right, so do you see what's going to happen with this 4 in the front now? This 4 is going to multiply through, boom, 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 boom. And when he does, cancel, 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 cancel. No more fractions. See why this road's easier? So then we'll have 9x squared minus 7x plus 3x squared plus 49 minus 21x minus 21x plus 9x squared equals 35. No more fractions. Lot of mess, but no more fractions. So now we're getting there. So this road is easier. It's easier to start with y. So you okay with that? Can I go to a fresh screen? Am I racing ahead of you? So we get, the question is this, is number 4? So 9x squared minus 7x plus 3x squared plus 49 minus 21x twice plus 9x squared equals 35. Like that. And then 9x squared and 3x squared is 12. And 9 more is 21x squared. And then minus 7, and what's that? Minus 42 is minus 49x. Plus the 49 equals 35. Just kind of combine like terms there. Is that okay? No more fractions. That's nice, huh? And now what should we do with that thing? What's our next step?
Get a 0 on this one.
Get a 0, right? So subtract 35. Gets us that 0. 21x squared minus 49x plus whatever that is, 14. All right. You could factor 7 out of all those. That'd be nice. 3x squared minus 7x plus 2. I don't know if you noticed that. 7 goes into all those. And you could probably factor what's left, or you could do the quad, whatever you prefer. That's 7. If that 7's bugging you, just divide it on both sides and it's by 7. 0, because 0 over 7 is just 7. Just get rid of it. Just divide on 7 on both sides, huh? So we're getting closer. It's getting a lot nicer. So now you can, if you're a good factorer, you can just factor that one. That one does factor, I believe. Yeah. Or you could just do the quad. That one factors 3x, x, minus 1, minus 2 in that order. If you're good at factoring, if you're not quite as comfortable, you can do the quad, and you'll get the same 2 answers. Answers are going to be 1/3 and 2, aren't they? Do you see them coming? On that. So I'm going to go to fresh screen if that's okay. So this is still number 4. 3x squared minus 7x plus 2. Yeah, so I'll do the quad, as I know a lot of people don't like to factor a lot. Negative b plus or minus square root of b squared minus 4ac all over 2a. So you could just do the quad, get your a, got your b, got your c. So negative 7 plus or minus square root of b squared minus 4 times a times c all over 2a. So x is 7 plus or minus the square root of 49 minus 24 over 6, which is 7 plus or minus square root of 25 over 6. Bring it up here. That's 7 plus 5 over 6 and 7 minus 5 over 6, which is 12/6, which is 2, or 2/6, which is 1/3. 2 and 1/3. which is the same two answers we saw here, right? This will be x is 2. And this, if you solve for it, it's going to be 1/3 when you move the 1 over and divide by the 3. Same two answers. 2 and 1/3 by quad or by factoring. Those are the two x answers. Now we got to go get the y answers, right? So take each of those two x answers and get a y answer. So these problems never end, do they? So x is 2 and x is 1/3. So now we got to plug in. Where are we going to plug in? Wherever looks easiest. Go back to the beginning. Definitely that second equation, 3x plus 2y is 7. So plug into that one. 3x plus 2y is 7. 3x plus 2y is 7. Plug in the 2. Plug in the 1/3. And we get 6 plus 2y is 7. Subtract 6. 2y is 1. Divide by 2. There we go. So the answer is 2 for x, a half for y. And the other one, 3 times the third plus 2y is 7. 3 times the third is 1. So 2y is 6. Divide by 2. Y is 3. So the answer is x 1/3, y 3. Whew. There we go. That's a ton of work. But very good for you. It's like exercising. Algebraic exercise. Make you strong algebraically doing all that will. That's what you need for calculus. Is that okay? Questions? I was going to show you a trickier way too, huh? It's not a lot better, and I'm tired of doing this problem for maybe I'll just show you the beginning. Everybody got that down okay? I'll show you the first step. There is one thing you could do that would make it even a little, not a lot easier, but a little easier. Let me just show you. This is maybe what a little more experience will show you. As you look at this top equation, well, here, let me just do it again. Here's even a better way, but here's the best way. The best way, if you take that top equation, 3x plus 2y is 7. If you look at plugging, when I look at solving for something and plugging into this other equation, here's what you can look for. You can look here and say, okay, look, I don't have to get y alone. I could just move the 3x over and just get 2y. 2y. And I can just replace 2y, not y alone. Why? Why would that be a good idea? Why am I seeing that would be nice? Because I have 2 and y right here. And what is 4y squared? 2y, 2y. So I'm looking at that thing going, oh, 2y and 2y, 2y. Going, oh, that way I can avoid fractions. I can just find out what 2y is, no fractions, and pop in for 2y. Instead of popping in for y, pop in for 2y. Because all the y's have a 2 next to them. Do you see that? So then this would become 9x squared minus, what is this? This is x times 2y, right? Isn't this term x times 2y? And what's 2y? 7 minus 3x. Like that, right? Plus, and then what is this? 2y, 2y. And what is 2y? 7 minus 3x. 7 minus 3x equals 35. Never touched a fraction. See how that avoids fractions completely? It'll be the same answer, just a little easier. That way you don't have to mess with fractions. So just another option for you. That way you can avoid fractions. All right, we've done that problem. Okay, so number 5. Let's take the first equation here. X squared minus 5y squared plus 64 equals 0. Okay. So, oh, by the way, the two equations are same level. One of them is not any easier than the other, right? They're equally easy, hard, whatever you want to say. They're equal difficulty. So I'll just grab the first one, I guess. Doesn't really matter. So anyway, notice everything is squared, right? There is no there's no x to the first power anywhere. There's no y to the first power anywhere. So what? So what am I going to do then to do the plug-in thing? I'm going to solve for like x squared in the first one, for example. I could just solve for x squared in the first one and plug into the second one. Be good with that? So I'll just say, okay, grab the first one, jump this to the other side, jump that to the side. So x squared is 5y squared minus 64. And then plug that in for x squared in the second one, right? So we just actually plug in for x squared rather than just like regular x. Everybody with me? All that gets plugged in right there for x squared. Is that good? So then we get 5, and then x squared. What is x squared? 5, right here it says x squared is 5y squared minus 64. Plus y squared is 96. Everybody see that? So I don't need to put a square on this, do I? It's already x squared, isn't it? Right? The whole x squared is 5y squared minus 64. I'm not just plugging in for x. I'm not just replacing the x and the 2 power is still there. No, I'm replacing the x, the 2 power, the whole thing, the whole x squared. Aren't I? Everybody see that difference? So then we just solve from here. Distribute. So we get 25y squared minus, what was that, 320, I think? Yeah. Plus y squared is 96. Like that. So we're going to solve for y there. Is that good? Can you do that? So go ahead and solve that for y. So solve that for y. So I'm going to go to fresh screen. You get that? Okay, so 25 is number 5. 25y squared minus 320. So gather like terms. 25y squared and one more y squared is 26y squared. Add the 320. So 26y squared is, what's that? 424, 416. And then divide by that 26. So y squared, is that something nice? 25? No. I don't know. 16? 16, isn't it? Yeah. That's nice. That's when you know this problem's working out, right? So, all right. So then you go, okay, square root, up and down the ladder. Y is plus or minus 4. Good there? Now I want to show you something. There's one. The reason I'm doing this, and there's one little extra thing that's actually easier, and I want to show you so you can save time and effort here. So we got y is plus or minus 4. So we got our answer for y, plus or minus 4. What are we to do with that now? We do not have to separate them. Everybody good to there? Can I go to fresh screen? So number 5. We don't have to go y is plus 4, y is minus 4. No. We can just do it all at once and just go y is plus or minus 4. Why? Well, because all the equations have everybody's squared. There's no y to the first power. There's no x to the first power. So positive and negative makes no difference, does it? You're only plugging into squared. So there's no difference between squaring a positive 4 or squaring a negative 4. It's 16 either way, isn't it? Positive 16 either way. So you don't have to separate the plug-ins. They're going to both result in the same thing, aren't they? So I'll just do the top one. What is it? X squared minus 5y squared plus 64. X squared minus 5y squared plus 64. Equals 0. So take plus or minus 4, both of them at the same time, and plug in there. And you get x squared minus 5 plus or minus 4 squared. Doesn't matter. It's going to get, what's that? 16 And so that's x squared minus 80 plus 6 squared. X squared minus 16. And then add it over. 16, roof on the house, up and down the ladder. So x is plus or minus 4. So what does that mean? That means plus or minus 4 for y leads to plus or minus 4 for x. So that means there's actually 4 different answers, as you saw in my answer thing. It's 4 with 4, negative 4 with positive 4, positive 4 with negative 4, and negative 4 with negative 4. 4 different possible answers. There it is. All right, I'm getting a little tired of these at this point. We good? These are all kind of the same. Little math. I want to show you the little messy parts there. We good there? Questions on that one? Okay, so this one, x squared plus 6xy equals 8. Yeah, so what are we going to solve for to plug in? I think it would be easiest. So see how they're the same? It says x squared and xy, x squared and xy. They have the same kind of like terms. I think it would. You could actually do the addition method too, by the way, if you prefer. I would just solve for x squared rather than x. I don't want to get x alone. That'd be why. Why don't I want? Yeah. Why am I looking at that saying I don't want to get x alone? Fractions. See what would happen if I got x alone? Fractions, right? Everybody see what I mean? If you jump that x squared over there, don't do this. Let me just show you. You'd have to divide by 6 and y. 6 and y, 6 and y. And then I had all those messy fractions. I don't want to do that. I don't want to go there. I don't want to mess with all those fractions. So what could I do? Just get x squared alone. And just because there's an x squared in the other equation, right? And I could just plug in for x squared. So just jump this guy over there. Get x squared equal 8 minus 6xy. And then just plug in for x squared in the second equation. Right? Take this and put it in right there for x squared. Is that good? And then you'll be able to solve for xy and then plug that back in and you'll be able to get all the answers. You guys all get that? Okay, let me jump in here. So 2x squared would be 8 minus 6xy. I'll just leave xy. So good to there, right? So the whole x squared is replaced with 8 minus 6xy, right? Like that. And then we'll just distribute, boom and a boom. I'm going to get 16 minus 12xy minus xy is 3. And then this is minus 12xy and minus 1 more xy is minus 13xy. Pretty good to there. And then subtract 16. And we get minus 13xy is minus 13. That's nice. And so then divide by minus 13. xy is 1, isn't it? Did y'all get to there? Xy is 1. So now, we still don't have x alone or y alone, but we're real close now. Now that we know that xy is 1, we can go back and plug into either equation and things will start happening real quick. So we good to there? Can I go to fresh screen? We good? So we know xy is 1, so this is number 7. So number 7, so we know that x times y is 1. And then I'll just take the first equation, x squared plus 6xy equals 8. X squared plus 6xy is 8. And I'll plug that in right there. So I'll get x squared plus 6. And what's the xy? 1. Good to there? That xy is 1. And then we got x squared plus 6 is 8. Subtract 6. X squared is 2. Roof on the house, up and down the ladder. X is plus or minus root 2. We got x. Now, let me ask y'all, do I need to separate, do I need to do like the separate this time, like the plus root 2 and the minus root 2? Do I need to separate them, or can I just plug them both in at once this time? I must separate them. How do I? Why do I have to separate them? In the last one, I just said, "Hey, plug them both in at the same time." Makes no difference. Why does it make a difference this time? Why do I have to separate them? Because one of the x's is not squared in the original. Remember, if any one of them is not squared, then there's a difference between negative and positive, huh? So the only reason I could do both at once last time is because all the x's were squared. All the y's were squared. There was no x to the first. There was no y to the first. Okay, I think you got it. So yeah, so do it separate. Just plug it in. Doesn't matter which equation. I'll just do this one again. So x squared plus 6xy is 8. Plug in x here and here. So you get root 2 squared plus 6 root 2y is 8. That's 2 plus 6 root 2y is 8. Subtract 2 from both sides. 6 root 2y is 6. Divide by 6 root 2. Divide by 6 root 2. Boom, boom. Y is 1 over root 2. Multiply top and bottom by root 2. It's root 2 over 2. So x root 2 leads to y root 2 over 2. And I don't know what the other one is. I'm going to go dot, dot, dot. You could do the other one. Is that good? We solved a lot of these. Questions on that? I'll move along if you're good. All right. So 9 and 10. So we have y equals x to the 1/5. So what you just let that one be y1 in your calculator, and you put e to the minus 2x and y2, and then on your graphing calculator, you graph them. So step 1, graph them. Step 2, do the intersect. Do the intersect routine. You know what I mean? Find where they intersect. Remember how to do all that? So I'll go dot, dot, dot. You have any trouble with that, come see me. We've done that in the past, so it's not new. I'd be glad to help you, though, with your graphing calculator. In fact, I could probably just whip it out really quick. Go. Maybe you'd want to, too, and see if you've got it.
Professor?
Yes?
Just out of curiosity, would you be able to swap the y and the negative 2x and then try doing it that way?
Do what's that?
Swap the y and the negative 2x and then divide the...
Wait, yeah, I'm still missing that first phrase. Swap the y and the negative 2x.
You know how with that one power, I can't remember its name, where the thing in the power is like moved, or is that only with ln? Yeah, we'd have to have an ln. Okay. Yeah. Let's see, x to the 1/5, and the other one is e. Oh, where's my e? Oh, there it is. Is that e? Yeah, e to the power of minus 2x. All right, window graph. Hitting the graph button here. Let's see what we get. 6. Yeah, I'm getting a funny little graph. Yeah, maybe it'll work. I'm just going to hit second calc, intersect, enter. I got an answer. X equals point. How many? 2 places. 0.17. Did y'all get that? 0.17. Oh, and they probably want y too. Y is 0.71. Kind of funny. It's reversal of digits. So 0.17, 0.71. Yes, so this indeed is the answer. That's where they intersect on that. So I did it with a window, negative 10, positive 10, negative 10, positive 10, and it worked fine. Didn't have to mess with anything. We good? If you have trouble with the calculator, come see me. Be glad to help you with that. Last one. We have done this section thoroughly.
Y or both?
I'm sorry?
Is the solution X or is it Y?
They wanted X and Y. Okay, so on this one, solve the system. So what are we supposed to do on this one? Yeah, how are you going to use your this is calculator again, right? Isn't it? Yeah, graph calculator, yeah. So then let's use graph calculator. How are you going to use your graph calculator on that one?
Yeah, got to get y alone in both. I just want to make sure you're clear on that, right? To use our graph calculator, we got to get y alone. So take that first one, x squared plus y cubed is 1. Jump the x squared over. And then what do you do to finish solving for y? Cube root it, huh? So cube root, cube root. So y is the cube root of 1 minus. How do you put in cube root to your calculator? Well, you can raise it to the 1/3 power like that. You aware of that? So cube root means the thing to the 1/3 power, right? Remember that fractional powers are the same as roots? Do you want me to say more about that? This will be super important for you to know when you go to calculus, because you'll do some things with derivatives one way and then the other, and it's a real important rule to know. So you want to be really comfortable with the fraction powers become roots rule. So a 1/3 power is the same as a third root. Remember, I do the Scooby-Doo analogy. From the denominator, he can swing into the hook. That's the same thing. To be a 3 in the hook or a 3 in the denominator power is the same thing. A 1/3 power is the same as a third root. And so what that means is you can type it into your calculator. 1 minus x squared to the 1/3 power. Like that. The other one, you would just divide by x cubed, huh? So that'd be y1. y2 would just be 9 divided by x to the third. Type them in. Hit the intersect button. And you got it. Does that one come out nice? Did y'all do that one? Let's see. One minus x squared to the power of 1/3. And the second one is 9 over x to the third. Graph. I get a funny looking graph. I don't know if you do. Yeah, one clear intersection point. So it should be easy. Oh, it's giving me a little trouble with second curve.
Oh dear.
I got it. I got negative on 2 places. Hundreds negative or 1.88, comma negative 1.36. Did you guys get that? I had to jump around a little bit. When you hit the intersection routine, it says first curve, second curve. It wouldn't automatically go to the second curve. I had to move my cursor around a little bit to get it to jump. Sometimes you have to do that. So I had to. I don't know if that's probably it's the same. If you have a TI, probably the same thing you'll need to do. So because normally for intersect, I just hit enter, enter, enter. I just don't even think about it. It just boom, it just pops it out. But this time I hit enter, 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 enter a bunch of times, and it was asking me second curve. It wasn't happy, and then I realized I had to move left and right until I was on, and then up, down, jumps between curves. Maybe I should say that. Here, let me show you. Maybe I should show you a little bit more what I'm talking about here. So let me go back and hit graph. So when I graphed, I got that. Did you get that graph? That was the first graph, and these 2 branches were the second graph. Here's the intersection right there. Right? My window's negative 10, positive 10, negative 10, positive 10. Graph those 2 functions. So the first one is this upside down U thing. The second one is these 2 branches. So anyway, so then I go to second calc, go down to intersect, enter, and see what it asks me. Which one's the first curve? I normally don't even look at the question. I just go enter, 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 and it normally just pops me the answer right away. When I try that this time, I go boom, 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 boom. Well, actually now it's working. Sorry. I'm meaning to show you it not working, but now I've moved the cursor to the right spot, so now it's taking it. So here, let me quit that, graph it again, and do it one more time. So I had to go down to calc, go to intersect. So first curve, it just wants to know which is the first curve, which is the second. So right here, see how I'm on the first curve here? See my cursor moving? Just say, yeah, that's it, enter.
Okay, so now which one's the second curve? It's saying, am I on your second curve? Well, yeah, that is, these two branches together are the second curve. So it is technically on the second curve right there. It's just not in a very good place. If you push the up arrow, down arrow, it'll jump between graphs, between y1 and y2. Now remember, y1 is the upside down u, y2 is the two branches. So if I go down arrow or up arrow, see how it jumps to the other one? I go down arrow again, it jumps back. So it's jumping back and forth between the two curves. I'm pushing up and down arrow. It jumps back. And if you go left and right, it moves along the curve. You familiar with that kind of thing? So I'll go up here and go, yeah, that's the second curve, enter. Now it says, okay, now what's a good guess? Is that a good guess for it to start? No, it'll never get over to here if I have it start. I don't think, if I hit enter here, it's going to have problems. Yep, it went out to Never Never Land, looking for the intersection. See, it can't get over to, oh, no, there it is. Just took it a little while longer. All right, it worked. So, good enough. All right, so hopefully you're good with all that. We'll go back. All right, I'm going to end this section.